In this section we're going to look at the effects of adding an acid to a buffer. In the first instance we're just going to work out the pH of the buffer. So it's propanoic acid. So we have our rearranged Ka expression. Let's just pop the numbers in now. We can see that the Ka for this acid is 1.32 times 10 to the minus 5. The concentration of the propanoic acid is 2.5 times 10 to the minus 2, and the propanoate ions is 2 times 10 to the minus 2. And this gives us a hydrogen ion concentration of 1.65 times 10 to the minus 5, and therefore the pH of the original buffer is 4.78. Now for the tricky part. So we're going to add some acid to the buffer, and we need to know what happens and how this will affect the pH. So we're adding 0.01 moles of hydrochloric acid, a strong acid, and the first thing that we need to establish is which part of the buffer will respond and write the equation for the reaction which takes place. So when we add hydrogen ions to the buffer, the part of the buffer that's going to respond will be the salt. In this case, it's the propanoate ions, and the reaction between the two will generate more propanoic acid, which means that our propanoate ions is going to go down slightly, and the amount of propanoic acid is going to go up slightly. By how much? Well, by however much acid we are adding. And we're adding 0.01 moles of hydrochloric acid, so that's 0.01 moles of hydrogen ions. Let's have a look at the moles that we had to start with. Well, the concentration of the propanoate ions was 2 times 10 to the minus 2 moles per decimeter cubed, and for the acid it was 2.5 times 10 to the minus 2. Now these are concentrations, but if the volume, as it says, is 1 decimeter cubed, that means that this is also the number of moles. So the salt is going to go down by the amount of hydrogen ions, and the acid is going to go up by that same amount. Which means the amount of propanoate ions will become 1 times 10 to the minus 2, whereas the propanoic acid will go up to 3.5 times 10 to the minus 2. Looking at our rearranged Ka expression, if we just pop our numbers in now. So we had 1.32 times 10 to the minus 5 for Ka. We've got the concentrations of the acid and the salt. I can just use the values of the moles here again. So we've got 3.5 times 10 to the minus 2 over 1 times 10 to the minus 2, which should give us an answer of 4.62 times 10 to the minus 5. This is our hydrogen ion concentration. So our pH is minus log of that answer, which is 4.34. And if we compare this to the original value of the buffer, we had 4.78. So we've added quite a large proportion of strong acid to the buffer, and the pH has dropped a little bit, which is what we would expect.